Hi there, you're in the lab with your mate JJ. Today is Module Monday. It's Module Monday. My silly job title for today is Connector Kingpin. Today I'm the Connector Kingpin. The module we'll be looking at today is another knock sensor similar to the one that we did last week. They're both in the same box. So I'll pull it out of the box and I'll bring it over to the bench and I'll show you what we're dealing with. Then we'll jump over to the computer and see if we can get some information about the vital statistics, and then we'll pop back over to the bench and we'll plug it into a Arduino Uno and write a simple project to use it. Should be pretty easy and pretty straightforward. So let's pop over to the bench and see what we're looking at. Here on the bench, looks like a bomb hit it. I've been working on various bits and pieces. This was the circuit I did the other day. I'll file that later on. We're done with that one. That was the circuit that I used an LED to suck energy out of the ambient light in the room. Now we've got our Arduino Uno at the back here, which is good because we'll want to be using that in just a minute. But let me just grab the module we'll be looking at today. It's in this box of modules called tap/shock. And I believe the one we did last week was the KY-002, which is in the back there. So today we're just going to look at this other type, which is the KY-031. And I am glad they go to the trouble of putting those little labels on them, because without them you'll never find the information that you're interested in. So this is another type of shock module. It looks quite a bit different. This clear plastic thing. I wonder if I can show you. Actually, I might even try and get the microscope on it. Give me a second, I'll be back. All right, I'm back. And if I just flip you over there, this is the microscope, and you can see the three inputs. On the left is negative, and on the left is signal, and on the right is negative, which means the middle one is VCC, or plus 5 volts usually. And then you can see the actual mechanism itself. It's sort of a spring-like looking contraption inside this this clear plastic box. So that's what that looks like. I'll flip him around. You can have a look at the back. It's just some solder, through-hole solder components, a couple of spacers there. In fact, there's a resistor pad that's not used. There you go. So they might use these for different types of boards. It's pretty common sort of breakout board, this form factor. So that's that. Now let's go over to the computer together, and we'll see what we can find on the internet about this thing. All right. Well, here we're on the computer, and we're over at AliExpress, and I've just put in the search for KY-031, and a few of them look about right, don't they? So this one looks about right. So does this one. This is not, this is not, this is, not, is, not, is. So got a couple of candidates here, 5 or 10 pieces, KY-031 knock sensor module for Arduino, 3-pin, percussion knocking, DIY starter kit, blah, blah, blah. Let's see if it comes with any code. No, just got some photos. Oh, looks pretty good. No code though. So what we're going to do is just quickly scroll through the listings and see if we can get any sample code, which might be helpful. There we go. So it's the old LED 13 output, pin 3 in. There we go. Set up input output, read and write, easy peasy. We've already got this program written from last time. It's the same program. It's just a different model, but the interface is the same. So that's going to be very easy for us. So let's go over to the bench and let's put this thing together. All right, well, here we are back on the bench. This is the one we'll be using. I think we had some, yeah, we've got some wires left over from last time, which is all well and good. We actually probably don't even need to change the program on this thing. If we just remember the right, pins for everything. So we've got positive, which can come out here. That's 5 volts, and it goes into the middle here. And then we've got signal on that side, so it's negative on this side, which we can do. And we just got to hook him up to ground. There'll be a ground on the board here. There's a couple of grounds. Let's use that ground there. Looks good enough to me. And then we want our input on pin 3. So let's put our pin 3 in. And 0, 1, 2, 3. There we go. All right. Now we are seeing a little flash there. Why are we seeing a little flash? Not sure. What happens if we knock the thing? Yeah, I don't know. Yeah, all right, well, we'll have to have a look at the code. So how are we going to do this? How do I show you the code? There we go. All right. So I'll throw you over there and you can see behind the scenes. That's all of the recording software that you can see there. Now, what are we looking for? We're looking for Arduino Uno, this guy here. So, all right, now this is the, okay. Are we going to do this? All right, I'll do this and I'll be back. Hang on a second. All right, I'm back. I'll throw you back over here. This is our code that I've been working on. I forget why I needed the Arduino.h library. Anyway, I've tidied things up a bit, so let's just run you through the code that we've got at the moment. We have defined an output pin for the LED, which is 13, but we're not actually using it, and I'll show you why in a second. The input pin here is pin 3. We've got a variable to receive the value that we read in our loop. From the pin, it will be either 0 or 1. Then I've got some information for counting some stuff. So I have a counter called count, and then I have an array of counters, which has just got two counters, one counter for 0 and one counter for 1. So then we do some timing stuff. So we initialize the milliseconds to 0, and then we nominate an interval, which is 5,000 milliseconds, which is 5 seconds. So this will set up 5 seconds. I'll show you that 5 seconds becomes relevant in our loop. Every 5 seconds we report our values. So that's every 5 seconds we'll be printing something out. I pinched this assertion from ChatGPT. It just checks a condition, and if it's not met, it outputs some debug information, and just hangs basically. Just goes into an infinite loop. So I tested it; it works. So that's all good. Now I used this serial put char. I also got this from ChatGPT. And it basically integrates with printf, and I'll show you how that's set up in a second. So when we do our setup, we set our LED to output, although as I said, we're not currently using that. And then we set our pin to input, which is what we're reading from our sensor. We set up our serial with a high baud rate, and then we wait until the serial is initialized. And then we set up the printf integration, which needs this static file, and then this, and there's a function pointer there to serial put char, which we defined before. And then we just printf console ready. So after the setup initializes everything, we just print console ready, and then we're done. Now here there's a helper function which came from ChatGPT, and this is how to print an unsigned long integer with commas in the thousands position spot. I didn't check this code, I just copied it in. And then this is the loop. So in the loop, the first thing we do is read a value from our pin. And then I make an assertion that the value is either 0 or 1, and if it's not, then I just crash. And that's good because we use that value as an index into our array, and we've only allocated 2. So 0 and 1 are valid, anything else is not valid. And of course, if we pass a wrong value into this array, we could be reading all sorts of dodgy memory if we're not inside a value that actually exists. So that assertion is pretty important. Although digital read should never read anything apart from 0 and 1 anyway. So anyway, so that's where we get, we increment our counter, and then we increment the specific counter either for 0 pin or 1 pin. Then we read the current millisecond value, and if the current millisecond minus the previous millisecond equals the is greater than the interval, then we reset the timer, and we print out some stuff. So the first thing we say is 5 seconds passed, and the count of values that was read. Then we calculate a total for the counters, and if the count doesn't equal the total, then we just print a debug message. Basically, the count should always be the total. So the count is split into 2 in the counters array. So when you add them together, you should get the same thing. So I just check that's right. And it is right. This message never comes out because these values are always correct. So this was just a little debug thing that I put in there. And then this helpfully prints out the number of counts for the 0 value, and then the number of counts for the 1 value. And having printed out the counts and everything, it just resets everything back to 0, and then it waits another 5 seconds for the next round. So hopefully that's clear. Now let's show you how this behaves. I'm going to press Control U, and that will upload after compiling. So that should all work. It's going to throw us over to the serial monitor. The console is ready. We wait for 5 seconds, and we get an output. And you see that there's about half a million, a bit more than 500,000 values read in 5 seconds. All right, so what I'm showing you here is the output of the console. I've cleared the space so you can, there's no logo obscuring these values, and you can see that they're coming out. There's about 500,000 of them every 5 seconds, and pretty consistently 552,552, and they're broken down about 283 versus 268, which is pretty even. Now what I'm going to start doing now is shaking the module, and you'll see the number on the left, the 0 value's gone up. It's gone to 349. I'm shaking it quite a lot now, and it's gone up to 385. And I'll give it a really good shake, and it's going to go up to 426, which is really quite high. And now I'm going to just let it calm down for a bit, so I'll stop shaking it. And the value has come back down to 274. So it's in equilibrium again. So it seems to be about equilibrium, and then the 0 count goes very high when there's a lot of kinetic energy, I guess, in the system, a lot of vibration or motion. So yeah, that concludes the demo of this sensor. So I'll throw over the farewell cam and we'll wrap up. And that's a wrap. So I'm not exactly sure what happened at the end of that video there, but we'll see when I put it all together to edit it at the end. But yes, this shock sensor was quite a bit different to the other shock sensor that we used. So when we used the KY-002, it would register like a knock event, and it would go down. It would just pulse down very briefly when the event happened, which I think actually is my preferred like form factor or behavior. If I was going to be detecting knocks, I'd probably want to just use the KY-002. But this one seems to be more of a vibration sensor, because it sort of picks up on vibrations. The more you vibrate it, the more 0 values you get. But it's a ratio, and it's not always high. I don't actually know how it works. It's got a spring in there, so there's some spring related thing. I don't get it completely. If you have something to tell me about it, I'd be very happy to hear from you in the comments about
about how that spring actually works and what those numbers actually mean and what is the best way to process them. I mean, obviously it's some sort of ratio thing, but I don't know what ratios are like special or what have you. But yes, I think that concludes this video. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.